Assalamualaikum and good day to everyone. So today we will start off with the first learning unit, which is Introduction. So this would be the outline for this learning unit. So you should be able to define food. Okay. Secondly, explaining chemistry of water, which include the fundamental properties or the structure of ice as well as water. Okay, and you have learned this before in other courses. And how does this structure of ice and water will affect food properties? Okay, and its availability also in food. Next is defining water activity. Now, what is water activity? Okay, and then lastly is explaining factors which contribute to food stability. Now we start off with definition of food. So what is food? Food is a substance that can be metabolized by organism, okay, like us human, to give us energy and as well for us to build tissue in our body. And the four basic food molecules are water, lipid, carbohydrates, and also protein. Okay, so this learning unit will focus on water. Okay, and the following learning units, lipid, carbohydrate, and also protein. So water is the predominant constituent in many foods. So meaning that most food will have water. Okay, just that some food will have less water compared to other food. Okay, so water is a medium which support chemical reaction. Okay, for example, enzymatic browning, microorganism growth, okay, lipid oxidation. So that is the role of water, okay, in food. So what is moisture content? Okay, so moisture content is when you press any food, okay, water that came out of the food, that come out of any particular food is the moisture content. Okay, and normally we use a percentage basis. Okay, so food like meat or milk as well as fruits and vegetables will have high percentage of moisture content. Okay, as you can see here, drier food like bread, okay, flour, coffee bean will have less moisture content. Okay, intermediate, you can say honey, okay, will have 20% of moisture content as well as bread. Okay, although it looks like a dry, okay, but the moisture content is rather high, 35%. So because water is a medium which support chemical reaction, which leads to food deterioration or food spoilage, so we have to remove water. Okay, so when we remove water, okay, from food, okay, it will improve the shelf life of food. Okay, so the food will last longer. And how do we remove water? Okay, by binding the water in food, okay, with the food component itself, okay, such as sugar, salt, glycerol. Okay, so go to the basic, which is water molecule. So we know it's the simplest and smallest cluster is H2O. Okay. Okay, so this is the structure of water, and by now you should be able to know this already. Okay, because you have learned this, and the arrangement for the H2O molecule would be in the tetrahedral arrangement, and the oxygen is highly electronegative. Okay, and due to that will be less repulsion between the hydrogen atom. Okay, which leads to the formation of the tetrahedral arrangement. Okay, so because of the dipole and tetrahedral structure, we have a strong hydrogen bonding between the oxygen of one water molecule with um, hydrogen of another water molecule. Okay, and this intermolecular um, forces, okay, electrostatic attraction between the hydrogen and oxygen is called hydrogen bonding. And water have the ability to form four hydrogen bonding with another water molecule. Okay, so you have 1, 2, 3, 4 here. So what actually determine how many hydrogen form? You should be able to answer this question. Okay, next we move on to ice. So ice will form exactly 4 hydrogen bonding, okay, between the adjacent water molecule. Okay, and to get this order, a lot of energy needs to be absorbed, okay, by the environment, okay, in order to form this um, hydrogen bonding. Okay, so the strong hydrogen bonding in ice, okay, will be in the orderly manner, okay, which is hexagonal crystal lattice. Okay, and this ice structure will have 4 times more thermal conductivity compared to water at the same temperature due to the lot of energy absorbed, okay, by the environment. So that's why it is um, exothermic. Okay, it's an exothermic process to form ice. So why does ice float? Okay, basically due to the density. So ice float because it is less dense compared to water. Okay, so the density for water is 1 gram per cubic centimeter, whereas for ice, the density is 0.931 gram per cubic centimeter, and that is why it float. Okay, now why is ice less dense than water if both are made of the same molecule, which is H2O? That's for you to think of. Okay, so this is the figure showing the structure of um, water and also ice. So this is ordered structure of ice. Okay, so this is less ordered structure of water. Okay, so based on this, actually explain the previous question, the previous slide. Okay, so in liquid water, okay, here each water molecule, okay, is hydrogen bonded to approximately 3.5 other water molecule. Okay, whereas in ice, Okay, each water molecule is hydrogen bonded to 4 other molecules. Okay, and that explains why, okay, ice float in water. So this shows the characteristics between water and also ice. Okay, so you can see the different in terms of its density, okay, in terms of the vapor pressure, okay, um, between the specific heat, okay. Okay, next we will move on to a new term for you, which is water activity, or denote as or written as A subscript W. So what is water activity? So it is defined as the ratio of vapor pressure of water molecule in the headspace above a foot, okay, to the vapor pressure above pure water at the same temperature. So if you have seen the video I posted through Elip, you should be able to visualize this. Okay, the video actually visualize this definition. Okay, so water activity is a measure, okay, how efficiently water which is present in food involved in chemical or physical reaction. Okay, so if the water is bound, okay, to a food molecule such as salt, sugar, protein, glycerol, okay, it will not involve in reaction which leads to the food deterioration. Okay, so therefore the shelf stability of the food can be prolonged. Okay, so the formula to calculate water activity therefore is partial pressure of water vapor above food, okay, divide with partial pressure of water above pure water at the same temperature. Okay, or we can use relative humidity, okay, divide with 100. Okay, and the scale for water activity is from 0 to 1. Okay, so 1 means is the water activity of pure water, 0 means no water at all present. Okay, okay, so due to the different level of water binding to food molecules such as salt, sugar or glycerol or protein, the activity and the availability in food sample will also be different. Okay, and that is how food stability is established. Okay, for food companies and regulatory agencies, for example, Food and Drug Administration, would rely on water activity as indicator, okay, of food stability. Okay, so based on that, okay, the food are categorized into three here. Okay, highly perishable food, okay, means the food stability or the expiry date of food categorized in highly perishable food would be short. Okay, where the water activity is normally more than 0.9. Remember the scale is from 0 to 1. Okay, example of highly perishable food like with short expiry date is yogurt, milk, fruits, vegetables. Okay, so these are categorized as highly perishable foods. The second category is intermediate food. Okay, intermediate moist food, in which the water activity value is from 0.6 to 0.9. Means the expiry date for this kind of food is in the mid region. For example, it can last slightly longer than the highly perishable food. Okay, so it can last weeks. Okay, for example, bread. Okay, when you buy bread, it will last longer compared to fruits. Okay, or milk. And the shelf stable food is the third category, which is having a long expiry date. Okay, for example, biscuits, jam. Okay, so this will have water activity less than 0.6. Now, how are the food categorized into that three grouping just now is based on the free water and also bound water. So the shelf-stable food with long shelf life have less free water. Okay, free water means the water is available for chemical reaction. Okay, bound water means the food is bound is with the food component like salt, sugar, glycerol, and many more. Okay. So strongly bound, okay, water will disable chemical reaction that leads to food spoilage. Okay. So when we reduce the amount of free or unbound water, it will minimize undesirable chemical changes that normally occur during storage that leads to the food spoilage. Okay. The all techniques, okay, for food preservation, when we don't have the technology like refrigeration, all that, we use drying. Okay, we use drying. Okay, we dry the food so it will last longer. Okay, for example, like your great grandpa, they buy fish or they caught fish. Okay, but they cannot consume all of the fish they caught, so some of the fish are dried under the sun, okay, to prolong the shelf life, although it will change the texture of the fish, of course. But then there is one of the old method to increase the shelf life of food. Okay, so we can increase shelf life of food by freezing. Nowadays we can freeze the food, or we can dehydrate the food. Okay, or we concentrate. Okay, we concentrate the food means we bound the free water, okay, to sugar, for example. Okay, so when we freeze, okay, food in order to prolong the shelf life, the free water is in the form of ice. Okay, ice crystal. So ice crystal is unavailable for the microorganism to grow. Okay, so that's why when you buy bread, for example, okay, Okay, let's say the shelf life of bread is 2 weeks. Okay, so you put the bread inside the fridge, and the shelf life can be longer than 2 weeks. Okay, because um, the water, okay, the free water available for microorganism to grow, okay, cannot do that. Okay, so next we will look at sorption isoterm. So what does isoterm mean? Okay, so isotherm is a plot of moisture content, okay, versus water activity. Now, um, it's not simple concept that high water content leads to high water activity. Generally, yes, but the relationship is not linear. Okay, it's not linear. Okay, normally food chef stability is determined based on water activity, but not water content. Okay, so what does water content mean? Water content mean, let's say you get a food, you press the food, and you get the juice out. For example, you get one orange fruit, okay, and then you press to get the juice out. So the juice extracted out of the orange is the water content of that particular fruit. Okay, water activity is different thing. Okay, based on the definition in the previous slide. Okay, so the relationship between water content and water activity is sigmoidal or curve shape, and this is what we call sorption isotherm. So notice here, the pathway for the adsorption is different from desorption. Okay, let's say we start off with a dry food with zero water activity value. Okay, very dry food. Okay, uh, for example, let's say um, milk powder. Okay, milk powder, and then that milk powder we add water. Okay, so we add water through the adsorption path. Okay, so we add water, and eventually the water activity is very high. Now, let's say we remove back the water, so means we dry. Okay, the milk powder undergo drying. Okay, undergo drying, then the desorption path will no longer be the same as the adsorption path. Okay, and this will create hysteresis, and this is we call hysteresis here. Okay, the one in this space here. Okay, and why is that so? Okay, this is due to the bottleneck theory. Okay, you can look up for bottleneck theory. So the concept is very simple. Let's say you have a bottle, something like this. Okay, okay, so when you add water to food, okay, let's say you have the food here, when you add water inside, okay, water, so it will fill up this vessel here until it reach the neck here. Okay, so this is adsorption. When desorption occur, you have to remove water from the deep capillary, okay, which is the narrow neck here, which is difficult compared to when we have a wide space in order to remove water. Okay, so it's difficult to remove water from the deep capillaries compared to the surface, and that's why you see a different um, uh, curve here between adsorption and desorption. Okay, so this is the moisture sorption isotherm. Okay, so I have explained this, the different path of adsorption and desorption. Okay, so hysteresis is exhibited by many food. So if you take different type of food, okay, and it undergo the adsorption and desorption procedure, you will get the same pattern. It will create a hysteresis. Okay, okay, so a hydrated food can be dehydrated in order to remove moisture until a desired water activity is reached. Okay, so desorption, when we start from wet state or completely dehydrated and then rehydrated again to reach desired water activity. Okay, through absorption. Okay, so a food is actually more stable against microbial spoilage when water activity is adjusted by absorption rather than desorption. Remember the bottleneck theory. Okay.